Chapter 6 is all about probability in statistics. So section 6.1, we're going to discuss the role of probability in statistics, and that is truly statistical significance. Now, this is something we're going to go into more in depth in chapters 8, 9, and 10, but it's a good idea to get a gut feeling for what statistical significance is. Here are our learning objectives. Statistically significant. A set of measurements or observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. Something is statistically significant if it's unlikely to have occurred by chance. There has to be a cause. So let's look at this first example. Considering the global average temperature, the 15 hottest years from 2001 to 2015 were 15 of the 16 of the 16 hottest years on record up to 2015. And that's using records that go all the way back to 1880. Would you say having 15 of the 16 hottest years on record occur in a single 15-year period is statistically significant? Yes, they're really close together. There has to be some underlying cause, i.e. global warming, not a theory. So that would be statistically significant. Let's take a look at the second example. The team with the worst win-loss record in basketball wins one game against the defending league champions. So the worst team wins one game against the best team. Would you consider that to be statistically significant? Has the team improved that much? No. Maybe that'd be significant if they beat the team like 10 out of 11 times or 9 out of 11, right? But just winning one, that's not going to be statistically significant. So I wanted us to first get a real gut feeling for what statistically significant was before we start bringing in later chapters how to calculate whether something is statistically significant. So let's look at this third example. A researcher conducts a double-blind, we know what that is, experiment that tests whether a new herbal formula is effective in preventing colds. During a 3-month period, 100 randomly selected people in a treatment group take the herbal formula, while another 100 randomly selected people in a control group take the placebo. The results show that 30 people in the treatment group got colds compared to 32 people in the control group. Can we conclude that the herbal formula is effective in preventing colds? Let's think of statistical significance. So in my treatment group of 100 people, 30 out of 100 got colds, compared to those in our placebo group, which was 32 out of 100 got colds. Do we think that this herbal supplement works in a statistically significant enough way? No, 30 and 32 are really, really close. So I want you to kind of think about what number would have had to get colds in our treatment group in order for you to feel like it was statistically significant. Would it be 15, almost half of those who got sick in our placebo group? Would it be 10? Would it be 5? Okay, try and get a gut feeling for yourself of what you think would be statistically significant. Let's talk about quantifying statistical significance. So in general, we determine statistical significance by using probability. This is something we briefly talked about in my finite math course. So hopefully you've seen it before. Otherwise, there are more links to videos on probability. To quantify the likelihood a result may have occurred by chance, we therefore want to ask questions like this one. Is the probability that the event occurred by chance less than or equal to 0.05, that'd be 5%, or 1 in 20? In order for something to be statistically significant, we need the likelihood that it occurred by chance to be less than or equal to 1 in 20. So, how to determine if a result is statistically significant? If the probability that that event occurred by chance is less than or equal to 0.05, we say that event is statistically significant at the 0.05 level. If the probability that our event occurred by chance is greater than 0.05, then our result is reasonably likely to have occurred by chance, and we say it's not statistically significant. We don't go any bigger than the 0.05 level. We wouldn't say 1 in 10 doesn't feel statistically significant, so we would never go to 0.10 level. We could go greater than 0.05, and that would be 0.01, the likelihood that it occurred 1 out of 100 times. If the probability of an event occurring by chance is 0.01 or less, then the event result, we would say it's statistically significant at the 0.01 level. So there's a 1 out of 100 probability that that occurred by chance. So in the test of the polio vaccine, 33 of 200,000 children in the treatment group got polio, while 115 of those in the control group got polio. They did a precise calculation, we're going to talk about how they did this in future chapters, and found that the probability of this difference in our groups occurring by chance was 0.0000000, so many zeros too, or 0.0000002%. Would you say that this is statistically significant? Yes. Yes. Not only is this much less than 0.05, it's also a bunch less than 0.01. So we would say this is statistically significant at the 0.01 level. Note, just as we don't want to go greater than 0.05, we don't want to go less than 0.01. We wouldn't say that this is statistically significant at the 0.000000001 level, right? We don't want to go greater than 0.05 or less than 0.01. And that's what we're going to talk about all through chapters 8, 9, and 10.